This is 1-7, transformations in the coordinate plane. Try the warm-up, hit pause on the video, and hit play when you're ready to see the answers. Here are the answers to the warm-up problem. Make sure in number 1 that you have a line, so it has to have arrows on both sides that divided the angle in half. And on number 3, I highlighted the x values together, so the 3 I knew equaled the x plus 1, and I solved my equation. And I did the same thing for the y's in blue. So a transformation is a change in the position, size, or shape of a figure. So our original figure, usually lettered with capital letters such as triangle ABC, would be our pre-image, and then what we get when we perform the transformation to the image results in the image, the new image. And we use little prime symbols, looks like an apostrophe after the capital letter, to represent that that is the new image after the transformation occurred. So there's 3 different transformations that we're going to focus on right now. A reflection, also known as a flip, a rotation, which is a turn, and a translation, which is a slide. And we're going to use arrow notation to describe transformation. So I'll show you what that will look like in example 1. So in example 1, we have our blue figure, which is our pre-image, and our red triangle, which is our image. And I know it's our image by the prime symbols that I see on each of these shapes here. And so I like to actually list out the coordinates. So let me do that for you. -1, 1. B is -1, 3. And C is 1, 2. And I'm going to do the same thing for the A prime. So A prime is, I can see that the A's are the A to the A prime, it spun. It was a turn, and so that is -1, -1 now. And B prime is -3, -1, and C prime is -2, 1. Okay, so we need to see what happened for all of these. The point A is going to be a little bit more challenging because they're both 1s, but if I look at what happened from like B to B prime, an ordered pair, the XY went to, now if you notice the 3 switched places and it became a negative. So that means the Y switched and became the opposite sign, a -Y. And then for the X, the -1 stayed the same. It's just that the X moved to the end. So it was -1, 3, and then it became -3, -1. So I'm trying to see what happened to each one. And so this is arrow notation. This is my mapping of this transformation. And I know that it's a rotation 90 degrees counterclockwise. So I listed the coordinates for example B, and I want you to see that from D to D prime, what happened was the x's stayed the same. Let's highlight those. The x's remained -4, but the y value went from 2 to -2, so it became the opposite sign. So in my regular coordinate xy, the x stayed the same and the y became the opposite sign, so I'd write that as -y. And so that's my mapping of this transformation, and I know that this is a reflection because it actually flipped over the x-axis. So it's a reflection over the x-axis. Okay, example 2, we have 1, -1 is A, 2, 3 is B, 4, -2 is C. And so we have our triangle ABC. That's my pre-image. And then my image is going to be a prime, negative 1, negative 1. Notice I marked the letters on the grid. That's because it makes it a lot easier to see what kind of transformation is occurring. Negative 2, 3, which is b prime, and negative 4, negative 2, which is going to be c prime. And if I look and see what's happening, it's looking like a mirror image or a flip. So it's a reflection over the y-axis. And what I can actually do if I want to just get used to this, it doesn't ask for this time, but the arrow notation, one ordered pair. So if I look at, well, I told you I don't like to look at the ones, it's too confusing. But if I look at b and b prime, the x became the opposite sign, 2 went to negative 2, but the 3 stayed 3, so the y value stayed the same. And it's the same thing for ordered pairs c and c prime. Oops, that's missing a prime symbol. But the 4 became negative 4, so the x became opposite sign and y stayed the same. So that is my arrow notation for that. You can also use arrow notation for translations, and those would include addition and subtraction in them for moving up and down or left or right along the grid. So it says find the coordinates for the image of triangle ABC after the translation. So let me give you a triangle because there isn't one here. Okay, I've given you a triangle ABC. It's on the graph now. And I also listed out the coordinates to make your life a little bit easier. And what I need to do to each of these is I have to map it using this, x plus 2 and y minus 1. So my a prime, I'm going to have to add 2 to the x value, which would make it negative 2. And I'm going to subtract 1, because it says y minus 1. So 4 minus 1 is 3. And now b prime, same thing. So x plus 2, negative 4 plus 2 is negative 2. And then y minus 1, so 1 minus 1 is 0. And c prime, negative 2 plus 2 is 0, and 1 minus 1 is 0. So I ended up with negative 2, 3 as my a prime, and negative 2, 0 as my b prime, and 0, 0 as my c prime. So if I redraw this triangle, does it look like I translated or slid this triangle for the x value positive 2 along the x-axis would be to the right 2, and for the y value negative 1 would mean that it would drop down 1 along the y-axis. So did I travel to the right 2 and down 1? Yes, I did. Example 4. The figure shows part of a tile floor. Write a rule for the translation of hexagon 1. Hexagon 1 I'm highlighting in blue to hexagon 2, which is in red. And it's telling us it's a translation. So all of my translation maps are going to go xy with an arrow. And it's going to be x plus or minus something, comma, y plus or minus something. So if I pick any ordered pair, like say I pick this ordered pair on the bottom right, and I'm trying to get to that ordered pair there, then I want to see how many spaces to the left did I travel. So 1, 2, 3. That means it would be negative 3 on the y-axis, and then up maybe half, 1.5. And we could see if that works for all the ordered pairs. So if I try it from this coordinate to that coordinate, let's see what happens. We go to the left, 1, 2, 3, and then up 1.5. Yep. So we could try that for all of our points, and it should work each time. So if I do this point mapping to this point, it takes me a second to see what I'm looking at here. So those are the same points on each shape. They correspond with each other. So 1, 2, 3 to the left, and up 1.5. So that is correct. X minus 3, comma, y plus 1.5, or y plus 3 over 2.